Welcome to homework.
Answer to Chapter 15, Problem number 4 from the Smith Organic Chemistry textbook. And this problem is asking us to draw all the possible products of a monochlorination of each of these alkanes. And so for A, it's cyclopentane. And remember, monochlorination conditions are chlorine gas and heat. And so when we treat cyclopentane with chlorine gas and heat, we get mono addition of chlorine. So basically, we're just taking a hydrogen and replacing it with a chlorine. And there's only one product drawn here because remember, all 5 of these carbons in this molecule are identical. And so really addition can happen at any of the carbons, but since they're all equivalent and identical, we can just draw this one product. So for B, the case is a little different. So B, I'm going to use red very quickly to demonstrate. B has a plane of symmetry here. So it's, a CH3, CH2, CH2 joined to its mirror image. And so for B, there are 3 possible points of chlorination. And there are 3 because really there are 6, but each carbon on this right side of this red line that I've drawn is identical to a carbon on the left side of the line. And so if we get chlorination at the first carbon or the last carbon, we would get this first product. Likewise, at the second or the fifth, we would get this product. And at the third or the fourth, this third product that I've drawn. So C is a similar situation. There are really only 2 types of carbon in this molecule. There's this central carbon that has 1 hydrogen, and then there are the carbons attached to it, which each have 3 hydrogens. And so each of these 3 methyl groups are identical to one another. And so we can either get monochlorination on the central carbon, which would give us this first product, or on any of the attached methyl carbons, which would give us this second product. And remember, because these 3 carbons are identical, we can just draw this single product. And that is the answer to Chapter 15.